All right, ladies and gentlemen, what we're going to do today is we're going to find the area of a sector of a circle. And the best way to think about this is sector means section of a circle. Okay, they kind of sound the same. They look the same when you spell them out. The definition is above here. I'll let you read that, but I want to show you exactly what a sector is. So when we did arc length, we were concerned only about the crust or the outside length of the circle. When we do sector, the sector is not only the outside, but the entire part of the circle inside. The best way I like to think about it is from this diagram over here. It's like, what is the space or the area of a slice of pizza? No longer do we care about just the crust. We want the entire area of this slice. Okay? The other thing we have to understand is notation. The notation of sector is with 3 letters, and we just use the word sector. So in this case, it's sector POQ. So if you look, it's P, O is the center of the circle, and Q is the other end of the sector, which means we're going from P to O to Q, which gives us this entire section of the circle. Okay, so we're going to be finding these things, and to find them, we have to know some formulas. All right, so let's move on. So the part of the sector, or the part of the formula we have to understand, is this guy here. Okay, very similar to arc length. If you notice, almost everything is identical, especially in this portion. We have the arc measure. As you recall, the arc measure is always in degrees. I'll put that little notation here. We're going to have this. This is the degree. So measurement in degrees. And then divided by 360. And then we put it equal. Here's our proportion. We're going to find the area of a sector, and we're going to divide that by the area of the circle. And as a reminder, the formula for area of the circle is pi times r to the second power. Okay, once we plug in the information, we cross multiply and solve for whatever we need to solve for. All right, so let's try example A. So we're going to find the area of each shaded sector in radians, so using pi, and we're also going to do it in decimal form. So we're going to answer this in 2 parts. The exact form using pi, and then we're going to do decimal form to the nearest 10th place. So every problem we do is going to have 2 answers. So let's go ahead and do sector POQ. So to do this, we use the formula arc measure divided by 360 equal to area of sector. So I'll just put sector to save space, divided by area of circle, which we know is pi times r squared. Okay, so again, we are just using this guy up here. So first off, we're going to put our degree of our arc. So we're looking for POQ. Notice we're looking at the shaded part. So this is the POQ we're talking about, the shaded area. Okay, so the arc measure is the angle of this, which is 210 degrees. So arc measure is going to be replaced with 210 degrees. Okay. We are trying to find the sector. So we don't know the sector, so I'm going to put it as X, the sector area. So let's erase this. We don't know what this is, so we'll put X in its place. And then we're going to find the area of the circle, which is pi times r squared. So we need to know what r is. And remember, r is the radius, so it's the center to the edge. So if you look, this measurement here is the radius, which we know is 3 inches. So we're going to plug that in to this formula. So it's going to be times 3 squared. All right, so let's work this out. First thing I want to try to do is see if I can reduce this, 210 and 360. So to reduce, we find the biggest number that divides the top and the bottom, and that number is going to be 30. 30 can divide the top and the bottom evenly. So we get 210 divided by 30. That gives us 7. 360 divided by 30, and that gives us 12. All equal to x, and then we're going to clean up pi times 3 squared. So 3 squared is just 9 pi. Clean like the x. And now to solve, we just cross multiply. So we're going to cross multiply 12 times x, so 12x, and then 7 times 9, that gives me 63, and the pi comes along for the ride. And now our job is to solve for x. So we're going to divide both sides by 12. So our answer is 63 over 12 pi. Now check, can we reduce 63 over 12? And we sure can. We can reduce by 3. So if I reduce 63 by 3, keep in mind when I say reduce, we're dividing by 3 in the top and by 3 on the bottom. X is going to equal 21 pi over 4. Okay, this can no longer be reduced. This is my exact answer. And then decimal answer, we're going to do 21 divided by 4 in our calculator and then times by 3.14. So 21 divided by 4 is 5.25, and then pi is 3.14, so times 3.14. Multiply that out, and you get x equals 16.48, and then we want to round to the nearest tenth, so we check. Here's our 10th. We want to cut off the number after the 10th spot, but we look at the number after the 100th and ask ourselves, is the 100th bigger, is 5 or bigger? And the answer is yes. So we're going to move the 4 up 1. So our nearest 10th, 6.5. So this would be our decimal. All right, that's example A. Let's go ahead and shoot over to example B. All right, so using the same formula, arc measure divided by 360 equals sector area. So sector area divided by area of a circle, which is pi times r squared. And then let's plug in our information. So we're trying to find the HGJ. So HGJ, so the shaded part. Our arc measure is in degrees, so we have 131 degrees. over 360. In our sector is what we're trying to find, so we'll put it as X. My radius in this example is 12, so I'm going to plug in 12 for R. And let's do the math. So here, I want to see if I can reduce. Off the top of my head, I don't see anything that would reduce, so I'm going to just leave it as 131 over 360. And then let's clean up 12 to the second. So 12 to the second, we get 144 pi. Okay, and now we can cross multiply to solve. 360 times x, 360x. And then 131 times 144. Let's throw that into our calculator. And that gives me 18,864. And pi comes along for the ride. And now we solve for x. So to solve for x, I got to get rid of 360 by dividing both sides. 360s cancel out. And then we divide. Alright, so we have to reduce this guy if we can. And since they're big numbers, this might take a little while, but I'll help you out here. So the first thing that comes to mind is I know that 8 will divide this. So 18,864 divided by 8. And 360 can also be divided by 8. If you throw that in your calculator to reduce, we got 18,864 divided by 8. That gives me 2,358 over 360 divided by 8. And it gives me 45. Okay, and don't forget your pi. We also, as I look at this, we can reduce again. I know the top can be reduced by 9. And so can the bottom. It can be reduced by 9. So if we do that, that gives me x equals 262 pi. And 45 reduced by 9 is 5. Okay, so again, it's a little, just some reducing that we have to do. I know the numbers are big. So that's why it's kind of important when we get to this part here, if we can reduce. I just didn't want to do it then. I should have reduced here. Okay, but we have this, and that is our exact form, or pi form, so exact. Okay, and now we're going to do decimal form. So this divided by this times pi. So x equals 262 divided by 5. We get 52.4 pi. And remember, we're going to use 3.14 for pi now because we want decimal form. So multiply that out. And we get x equals 164. If we round correctly, 5. Okay, that's my decimal form. And before we move on, I want to point this out over here. Area is measured in square units because we are measuring a space. We're not measuring a distance, we're measuring a space. So like, for example, we measured this space and it's in 2 dimensions. So whatever unit we used, in this case we used inches, our answer is going to be in that unit squared. So let me fix this real quick. So when we do this, it really would be in inches squared. Okay, so this would be the correct exact answer. You got to put your unit in there squared because it's an area, and this would also be inches squared. So IN to the 2nd power, and this is the decimal form. All right, and same thing over here. So we were using in example B, we're using meters or M. So it's going to be M squared when we have area. So let's clean this up. And then our exact will be M squared as well, or our decimal. Okay, so when you do an area, you always put your unit to the 2nd power. When you're doing a distance like arc length, you just put the unit without a power. All right, we will do C and D together in class and make sure we are comfortable with this.